a Wikividi Documentaries production. Don't forget to like and subscribe. Enjoy.
Starlink satellite constellation. Starlink is a satellite constellation development project underway by SpaceX to develop a low-cost, high-performance satellite bus and requisite customer ground transceivers to implement a new space-based internet communication system. By 2017, SpaceX had submitted regulatory filings to launch a total of nearly 12,000 satellites to orbit. By the mid-2020s, SpaceX has plans to also sell satellites that use the same satellite bus, and these satellites may be used for scientific or exploratory purposes. Development began in 2015, and prototype test flight satellites were successfully launched on February 22, 2018. Initial operation of the constellation could begin as early as 2019 to 2020. The SpaceX Satellite Development Facility in Redmond, Washington, houses the research and development operations for the Satellite Internet project. History. The communication satellite network SpaceX envisions was publicly announced in January 2015, with the projected capability of supporting the bandwidth to carry up to 50% of all backhaul communications traffic and up to 10% of local internet traffic in high-density cities. CEO Elon Musk believes that there is significant unmet demand for low-cost global broadband capabilities. The opening of the SpaceX Satellite Development Facility in Redmond was announced by SpaceX in January 2015 to build a new communication network. By January 2015, the Seattle area office planned to initially hire approximately 60 engineers, with the potential to increase to 1,000 people in the next several years. There were 45 open positions in October 2015. The company was operating in 300,000 sq-ft of leased space by late 2016, and by January 2017 had taken on a 40,625 sq-ft facility, both in Redmond. By January 2016, the company was planning to have 2 prototype satellites flying in 2016, and have the initial satellite constellation in orbit and operational by approximately 2020. However, by 2017, design changes had obviated the original 2 test satellites, and the launch of 2 revised satellites had slipped to 2018. In July 2016, SpaceX had acquired a 8,000 sq-ft creative space in Irvine, CA. SpaceX job listings indicate the office will include signal processing, RFIC, and ASIC development for the satellite program. By October 2016, SpaceX had developed test flight satellites that they hoped to launch in 2017, and they were focusing on a significant business challenge of achieving a sufficiently low-cost design for the user equipment, aiming for something that can ostensibly install easily at end-user premises for approximately. Overall, Shotwell said the project remains in the design phase as the company seeks to tackle issues related to user terminal cost. Deployment, if carried out, would not be until late in this decade or early in the next. In November 2016, SpaceX filed an application with the FCC for a non-geostationary orbit satellite system in the fixed satellite service using the Ku and Ka frequency bands. By March 2017, SpaceX filed with the FCC plans to field a constellation of more than 7,500 V-band satellites in non-geosynchronous orbits to provide communication services in an electromagnetic spectrum that has not previously been heavily employed for commercial communications services. Called the V-band low Earth orbit constellation, it would consist of 7,518 satellites to follow the earlier proposed 4,425 satellites that would function in Ka and Ku band. The March 2017 plan called for SpaceX to launch test satellites of the type in both 2017 and 2018, and began launching the operational Constellation sats in 2019. Full build-out of the constellation is not expected to be completed until 2024, at which time there are expected to be 4,425 satellites into orbit around the Earth, operating in 83 planes, at fairly low altitudes of between 1,110 kilometers and 1,325 kilometers. By September 2017, the planned number of sats in each constellation had not changed, but the altitude of each constellation became explicit. The larger group, 7,518 sats, would operate at 340 km altitude, while the smaller group, 4,425 sats, would orbit at 1,200 km altitude. Some controversy arose in 2015-2017, with regulatory authorities on licensing the communications spectrum for these large constellations of satellites. The traditional and historical regulatory rule for satellites licensing comm spectrum has been that satellite operators could launch a single spacecraft to meet their in-service deadline from the regulator, a policy seen as allowing an operator to block the use of valuable radio spectrum for years without deploying its fleet. The U.S. regulatory authority has set a 6-year deadline to have an entire large constellation deployed to comply with licensing terms. The international regulator, the ITU, proposed in mid-2017 an international guideline that would be considerably less restrictive. In September 2017, both Boeing and SpaceX petitioned the US FCC for a waiver of the 6-year rule. SpaceX filed legal documents in 2017 seeking to trademark the name Starlink for their satellite broadband network. By March of 2017, SpaceX had filed regulatory paperwork to launch approximately 12,000 satellites, including 7,518 sats to provide communications in the little-used V-band in very low Earth orbit. SpaceX filed documents in late 2017 with the US FCC to clarify their space debris mitigation plan. SpaceX will implement an operations plan for the orderly deorbit of satellites nearing the end of their useful lives at a rate far faster than is required under international standards. Satellites will deorbit by propulsively moving to a disposal orbit, from which they will re-enter the Earth's atmosphere within approximately 1 year after completion of their mission. SpaceX successfully launched 2 experimental satellites, Tintin A and Tintin B, on the 22nd of February 2018. Global broadband internet. 2 space entrepreneurs announced internet satellite ventures in the same week. In addition to SpaceX CEO Elon Musk announcing this project, serial entrepreneur Richard Branson announced an investment in OneWeb, a similar constellation with approximately 700 satellites that has already procured communication frequency licenses for their broadcast spectrum, after the failure of previous satellite-to-consumer space ventures. Satellite industry consultant Roger Rush said, "It's highly unlikely that you can make a successful business out of this." Musk has publicly acknowledged this business reality, and indicated in mid-2015 that while endeavoring to develop this technically complicated space-based communication system, he wants to avoid overextending the company, and stated that they are being measured in the pace of development. Nevertheless, internal documents leaked in February 2017 indicate that SpaceX expects more than $30 billion in revenue by 2025 from its satellite constellation, while revenues by its launch business are expected to reach $5 billion in the same year. In February 2015, financial analysts questioned established geosynchronous orbit communications satellite fleet operators as to how they intend to respond to the competitive threat of SpaceX, Google, and OneWeb LEO communication satellites. In October, SpaceX President Gwynne Shotwell indicated that while development continues, the business case for the long-term rollout of an operational satellite network is still in an early phase. In 2015, court documents indicate that SpaceX had engaged in collaboration with wireless chip maker Broadcom. 5 key engineers subsequently left to join SpaceX, leading to a lawsuit filed by Broadcom alleging that SpaceX stole our best minds. In March, an Orange County judge denied Broadcom's multiple restraining order requests, extending to use beyond Earth. In the long term, SpaceX intends to develop and deploy a version of the satellite communication system that would be used on Mars. In the mid-term, SpaceX is interested in the SATCOM system on Earth, generating revenue that would be helpful in providing capital for the company's Mars transport project. Internet communication satellite characteristics. The Internet communication satellites are expected to be in the smallsat class of 100 to mass, which are intended to be orbiting at an altitude of approximately 1,100 kilometers. Initial plans were for the constellation to be made up of approximately 4,000 cross-linked satellites, more than twice as many operational satellites as were in orbit in January 2015. The satellites will employ optical inter-satellite links and phased array beam forming and digital processing technologies in the Ku and Ka band, according to documents filed with the U.S. Federal Communications Commission, while specifics of the phased array technologies have been disclosed as part of the frequency application. SpaceX enforced confidentiality regarding details of the optical inter-satellite links other than that they will utilize frequencies above 10,000 GHz. The satellites would be mass-produced, at much lower cost per unit of capability than existing satellites. Musk said, "We're going to try and do for satellites what we've done for rockets, in order to revolutionize space. We have to address both satellites and rockets. Smaller satellites are crucial to lowering the cost of space-based internet and communications." In February 2015, SpaceX asked the FCC to consider future innovative uses of the Ka-band spectrum before the FCC commits to 5G communications regulations that would create barriers to entry. Since SpaceX is a new entrant to the satellite communications market, the SpaceX non-geostationary orbit communications satellite constellation will operate in the high-frequency bands above 24 GHz, where steerable Earth station transmit antennas would have a wider geographic impact, and significantly lower satellite altitudes magnify the impact of aggregate interference from terrestrial transmissions. The system will not compete with Iridium satellite constellation, which is designed to link directly to handsets. Instead, it will be linked to flat user terminals the size of a pizza box, which will have phased array antennas and track the satellites. The terminals can be mounted anywhere, as long as they can see the sky. Prototype development and testing. SpaceX began flight testing their satellite technologies in 2018, with the launch of 2 test satellites. The 2 sats were called Microsat 1A and Microsat 1B during development, but were named Tintin-A and Tintin-B upon orbital deployment in February 2018. The satellites will orbit in a circular low Earth orbit, at 625 km altitude in a high-inclination orbit for a planned 6 to 12-month duration. The sats will communicate with 3 testing ground stations in Washington and California. for short-term experiments of less than 10 minutes duration, roughly daily. Both microsats were originally slated to be launched into 625 km circular orbits at approximately 86.4 degrees inclination, and to include panchromatic video imager cameras to film image of Earth and the satellite. Microsat 1A and 1B were planned, as of June 2015, to be the first of up to 8 prototype sats to be flown before deployment of the operational constellation. At the time of the June 2015 announcement, SpaceX had stated plans to launch the first 2 demonstration satellites in 2016. But the target date was subsequently moved out to 2018. The 2 test sats were successfully launched to a sun-synchronous low Earth orbit on the 22nd of February 2018, and were renamed Tintin A and Tintin B.
Brought to you by Wikivideo Documentaries. Would you like to know more?